Recall that a power series is a function series whose terms are of this form for some sequence a sub n, called the sequence of coefficients, and some number c, called the center of the power series. A power series that converges to f of x on its interval of convergence represents f of x. By convention, a power series is said to represent a function only if its radius of convergence is greater than 0. In other words, we usually don't talk about a power series representing a function when that function is defined only at one point. Recall also that a function with a power series representation is differentiable, and its derivative is given by this formula. We got this by starting with the series for the original function and then differentiating it term by term using the power rule. We can find the second derivative in the same way to get this formula. In general, the formula for derivative I is this. This formula lets us find a nice expression for the a sub i's if we know the derivatives of f at c. To see y, let's replace x with c, and then note that x minus c is part of every term in this series except the first. So when we replace x with c, every term but the first becomes 0, leaving only this first term. The coefficient of a sub I here equals I factorial, so we can solve for a sub I. To summarize, if f of x has a power series representation centered at c, then that series has this form. Recall that every function with a power series representation centered at c is infinitely differentiable at c. That is, it has derivatives of all orders at c. This leads us to the following definition. Suppose that f of x is a function that has derivatives of all orders at c. The Taylor series of f of x centered at c is this series. Two remarks are in order. First, to have a Taylor series centered at c, the only requirement is that the function be infinitely differentiable at c. Second, we haven't assumed that f of x has a power series representation centered at c. In particular, we haven't said that a function must equal its Taylor series at c. From what we saw earlier, we know that if it has a power series representation at c, then it must be the Taylor series. We'll talk about functions equaling their Taylor series when we discuss Taylor's theorem.